Okay, so in this video I'm going to have a look at Prim's algorithm for making minimum spanning trees from a weighted connected graph. Now, just to remind you that a tree is a connected graph that has no cycles. A spanning tree is a subgraph of a particular graph that includes every vertex of the original graph and is also a tree itself. A minimum spanning tree then is a spanning tree with minimum total weight. So they're just the three definitions that we did in previous videos. Now I'm going to have a look at this particular graph here. We had a look at this in a previous video. This is a connected graph. In fact, it's what's called a strongly connected graph because every vertex is connected to every other vertex in the graph. So you can see that A, for example, here is connected to B, it's connected to C, D, and E. And it's the same for all the other vertices or nodes. So let's have a look at how we would work Prim's algorithm on this particular graph. So I'm going to start here with A. I'm going to start here with this vertex here, A, and I'm going to work from there. So what we need to do is look at the vertex that we have circled here in this case and find the minimum weighted edge from A. So if we look down along here, we've got 7 along here, we've got 5 here, we've got a weight of 9 here and a weight of 3 here. So I'm going to go from A to E here, which is 3. So I'm going to use this particular one here. Let's draw that. So we're starting with A and we're going to E, and that has a weight of 3. Okay, now we've included E here, so I'm going to just circle that. Now we have 2 vertices circled, so what you've got to do now is look at both of those vertices and look at all the edges from those 2 vertices and pick the edge with the least weight. So if we look at A here, we've got a 7, a 5, a 9, and we've already used 3, so we have 7, 5, and 9. From E we have 7, 5, and 8. Okay, so what I might do here, we have 2 5s, so what I'm going to do is pick one of them, and I'm going to pick this one here, this one down to C here. So let's just circle those. So I'm going to go down to C, and I'm going to pick this weight here. Let's draw that. So we're going from A to C, so let's just come out along here, and I'll put C here, and that has a weight of 5. Okay, so now I have 3 vertices circled, so we've got to look at all the weights of the edges from those 3 vertices. So let's see, I've got 3 which I've already used, I have 5 which I've already used. I'm looking at A here now, so I've got 9 and 7. From E I've got 7, 5 and 8, and from C I've got 6, 5 which I've already circled, 5 up along this way, and 10. So the smallest weight is going to be this 5 here. But the problem with this is if I did use this one here, what would happen? I would end up with a cycle from A to E, or A to C to E, so I'd end up with a cycle. And remember, we can't have any cycles, so I'd have to connect these 2 here, so I would end up with a cycle. Okay, so I'm not going to pick this 5 here. So the next weight that I'm going to look at then is 6, so I'm not going to use this one. Let me just get rid of that one there, and I'm going to use this one here, which is 6, and that will bring me up to B. Okay, so let's draw that one then. So we're going from C to B, so let's draw that. I'll just come down this way to B, and I'll put in that weight there of 6. So we have 4 of the vertices now, so we've 1 left. So let's look at all the vertices that we have circled and look at all the weights of the edges from each of those vertices. So let's have a look. We have 3 which we've already used. We've got 7 but we can't use this 7 here because we'll end up with this cycle here from E to B. So I would end up connecting these 2 here, which will give me a cycle, so that's not going to work. So again, I might just cross that out, so I can't use that one. I've got this one here already crossed out. Let's see, we have 7 from A to B. Again, I can't use that one from A to B because that will bring me from here to here, so that will give me a cycle as well. So I'm just going to cross that one out. A has a 5, which we've used. It has a 9 here. So from A to D. Okay, so I could use that one. Let's see what else we have. We have E, which is 3, which we've used, 7, which we can't use, 5, which we can't use, and we've got an 8. Okay, so we've got an 8 from E to D. So that's smaller than 9, so we can use this one. Let's have a look at C. C, we've got a 6, a 5, which we can't use, 5, which we can't use, and a 10, which is bigger than 8. So we're not going to use 10. We're still on the 8 here. From B then we can't use that one, we can't use that one, we can't use the 9 because it's bigger than 8. And we have a 6 here which we've already used. So it looks like it's going to be this one here from E to D. So from E to D. So I'm going to use this one here, and I'm going to use D then, which is my 5th vertex. So from E to D will bring me over to here, and that has a weight then of 8. Okay, so we have all our vertices used at this stage, so we're finished. This is our minimum spanning tree here, and the total weight is just going to be equal to 6 plus 5 plus 3 plus 8. So that's 6 and 5 is 11, 12, 13, 14 plus 8 is 22. Okay, so this is our minimum spanning tree here. This is our minimum spanning tree here, and this is our minimum weight here. Okay, so that's using Prim's algorithm, where we start with one of the vertices. It doesn't really matter which one. I started on A, but you can pick any one and you'll get a minimum spanning tree. Okay, so I'm going to do this same graph, but just a slightly different way. I'm going to use this matrix here. I'm going to use the tabular form or the matrix form of the graph. So you can see here I've just put the weights in a table here. Again, it's symmetrical around this diagonal here. We had this in a previous video. So you've got 7, 5, 9, 3, 7, 5, 9, 3, 6, 9, 7, 6, 9, 7, 10, 5, 10, 5, and the 2 8s here. So there are no loops, so A doesn't connect to A, B doesn't connect to B, so we've nothing down along the diagonal here. So this represents the graph that we have just done. So let's look at using Prim's algorithm from a matrix or from a table. These could represent, distances or flow rates or something like that. So let's start. Now again, you can start anywhere here. I'm going to start with row 1 here, or row A here. So I'm going to put a star next to row 1 or row A here. Now what you do is you just mark the particular row. I marked it with a star, and then you delete that particular column. So you can just put a line down through it to delete it. I can actually physically rub it out here, so that's what I'm going to do. Now you then look at the numbers in the starred row. So I'm going to look at these numbers here: 3, 9, 5, and 7. Now 3, 5, 9, and 7, the minimum weight there is 3, so I'm going to circle that particular one there. Now that particular one there, 3, that particular weight is in column number 4, or column E, so I'm going to put a star on row E. And I'm also going to delete, it's because I'm looking now at row E, I'm going to delete column E, except for the starred or the circled number, except for the circled number. So I'm going to delete these ones. Okay, so next thing I'm going to do here is look at the 2 starred rows. And I'm going to find a minimum weight in the 2 starred rows. So if you look at the 2 starred rows, you've got a 9, a 5, and a 7. You've got an 8, a 5, and a 7. So what I'm going to do is, there are 2 5s here. I'm going to pick this one down here at the end. I'm going to pick this one. You could pick this one. I'm going to pick this one here. So let's just circle that one. So I'm going to circle the 5. Now that's in column C. So I'm going to star row C. And I'm going to delete the remaining numbers in column C. And start again. Now I'm going to look at the 3 starred rows, and I'm going to try and find the minimum weight in those 3 rows. So I've got a 7, a 9, 10, a 6, a 7, and a 5. So the minimum one there would be 6. So I'm going to circle this one here. This is in column B, so I'm going to star that row B. and then I'm going to delete the remaining numbers in column B. And now I'm going to look at the starred rows and find the minimum weight in those rows. So I've got a 9, a 9, a 10 and an 8. So the 8 is the smallest one, so I'm going to circle that one. That's in column D, so I'm going to star row D, and I'm going to delete the remaining numbers in column D. So we're finished now. We've used all the vertices. So all I've got to do now is draw the minimum spanning tree. So let's start. We've got A to E here anyway, so let's have a look at that. So we have A to E, and that has a weight of 3. That is a weight of 3, so I'll put 3 here. We have, let's see, we have C to B. So C to B, let's put that, I don't know, let's say put it down here. C to B. And that has a weight, to B that has a weight of 6. Okay, so I've done that one, I've done this one. Let's do this one here, E to C then, we're going to do E to C. So E to C will come along here, and that has a weight of 5. So we're going to put 5 in here. You just change this particular color here to 6. In green, and now finally then we have an 8 here, so we have the 8 here, and that goes from E to D, so that goes over this way from E to D, and that has a weight of 8. Okay, so this is our minimum spanning tree here, so let's have a look at that. We have total weight. The total weight is going to be 3 plus 8, 5 plus 6, so that gives us 8, 9, 10, 11, 16, 22. So that's what we got up above when we did it from the graph, from the connected graph. Okay, so that's using a matrix form, just doing it by looking at a matrix form of the graph. Now, if I'd have picked, remember at the beginning here, I picked a 5 down here, I could have picked a 5 up here, I think it was. What would happen if we did that? We would get a different looking spanning tree, but we should get the same total weight. So let's have a look at doing it that way. So I should have another one here. So this is the same matrix. So let's start again. So I'm going to start again with row 1. So I'm going to put a star there, and then I'm going to delete this particular row, or sorry, I'm going to delete this particular column. And I'm going to look at the minimum weight in row 1 here, or row A, which is 3. Okay, so that's in column E, so I'm going to put a star next to row E, and then I'm going to delete the remaining numbers in column E. Let's look at the minimum numbers again, the minimum weights. So again, you can see here it's going to be 5. It's going to be this 5 or this 5 here. Now in the first one I did up above, I did this 5 here. So this time I'm going to pick this 5 up here. See what happens. So this is in column C, so I'm going to put a star next to row C, and I'm going to delete the remaining numbers in that column. Okay, so now I've got 3 stars here. Let's find the minimum weight here. So we've got, let's see, we've got a 7, a 9, a 6, a 10, a 7 and an 8. Well, it's going to be 6 here. So I'm going to use this one here. So I'll circle that. That's in column B, so I'm going to put a star next to row B, and then I'm going to delete the remaining numbers in that column. Okay, so now I'm going to look at, I've got 4 stars here, so I'm going to look at the 4 rows, look for the minimum number, the minimum weight in those 4 rows. So I have a 9 here, I've got a 9 here, I've got a 10 here, and I've got an 8 here, so it's going to be the 8. And that's in column D, so put a star next to row D and delete those numbers in that particular column. And you can see now we have all the vertices, all the numbers have been deleted except for the circled ones. So let's draw our minimum spanning tree now. So we've got AC, A to C, which is 5. So A to C here, and that's going to be 5. That's this one. We've got A to E, which has a weight of 3. So we're going to do that one. A to E, so let's put E here, and that has a weight of 3. We have C to B here, so C to B, that'll go out this way, so let's put B out here, and that has a weight of 6, and has a weight of 6. And finally we have E to D, so E to D, that's going to come out this way, E to D, and that has a weight of 8. Okay, so we have all of them, I think, at this stage. So let's have a look. We have 1, 2, 3, 4, 5. Yep. So let's do our total weight then. So our total weight then is 8 plus 3 plus 5 plus 6. So that's again 22. I think that was that similar to our original spanning tree. I think when we did it from the graph, I think we got a spanning tree that was a straight line like this. So let's just have a look. So it's way up here. Yeah, we got this straight line spanning tree. So the second way we got this kind of a spanning tree here, but the same weight, same total minimum weight, and here we got a straight line with a minimum total weight of 22 again. Okay, so that's it for Prim's algorithm.